Hello everyone. This is Vairasar from SND College of Engineering and Research Center from IT department, and my subject is operating system. So in the operating system, some every task we can say which is performed by the processes. We can say that processes. Okay. So what is process? So the program which resides on the hard disk are called a program, or the set of instruction we can say. The set of instruction is nothing but the program. The program which is on the hard disk is called as program. Okay, the set of instruction which is on a hard disk which is called as a program. When that program goes to the main memory for its execution, it becomes processes. So every task performed in operating system by the processes only. So we have to learn this topic today. Today we are going to see process. What is process actually? Process scheduling means which process will execute when that's supposed to be scheduled. That is process scheduling, and operation on processes. Okay, these three topics we have to cover in today's session. First of all, what is process, or the basic concept? What is process actually? Okay, so an operating system executes a variety of programs by the batch system, time shared system, user programs, or tasks. I just say that key processes or whatever task performed by the operating system, which is a task, or we can say it is a process. So the when it is a program, it resides on a secondary memory, and when it reload to the main memory for its execution, the program becomes process. A program in execution, process execution must program in sequential fashion. This program execution should be in sequential manner. That is process. Okay. So are you getting what I'm going to teach you? Process, the program which is on hard disk, which is reload to the main memory for its execution, called as process, or program becomes process. So what is the parts of process? So there is a text section is there, program counter is there, stack is there, data section is there, and heap is. Okay, in a one process that all five parts are there. In a text section, all the text parts are in text section. Program counter means your which number of instructions are executing, that is in program. Stack, that containing temporary data, means the data which is required temporary, that is in stack. Data section, so additional information required for that program, or we can say global variable which is declared on the topmost, that is data section. And heap section, that memory dynamically allocate for that during the runtime, means program in running mode, and that containing a memory which required that program when it is running, or additional memory is required, that is the heap. Okay, so five components or parts we can say: text section, text text format or text data, program counter, number of instructions or which number of instruction is executing, stack, temporary data, data section which containing the variables, global variables, and heap section, dynamic memory required. What is the difference between process and program is that key program is a passive entity which is resides on the hard disk, whereas process is an active entity which is running in mode. So it is a active entity, and program is a passive entity. So program need not need anything because it is in passive mode, but Process require too many things. Program requires memory. Program requires data, we can say. Process requires too many files for complete its execution. Okay. See, this is the process in memory. Okay. Stack. This is the we can say the empty part. This is heap. This is data section, and this is text section. Okay. Process state. This point is very important, and which is uh, I can say too many times asked to the in examination. Okay. So what are the steps are there, or what are the states are there? As human being is born, he has a state of its life. He's born, then he's go to the his child mode, then it go to be in then he or she go in her teenage, then she we can say adult stage, then old stage, and then she or he goes on. Okay, so this is the life cycle of us. So same, we can say life cycle also, we can say states also. Okay, so we will see in a diagrammatic format. So whatever process are created with the state of that process is a new state. This process is created is in new state, and then that process will go to the ready state when it ready for the execution. Okay, then that process change its execution from change its state from new state to ready state. Okay, then the process are ready for execution. Okay, the process are ready for the execution. That process are reside in the ready state. When that process in ready state, they are waiting for the CPU, and when that process is allocated to CPU, which will go to the running state. Okay, the process in running state means the process execution is going on. When process execution is going on, it is in ready state. Suppose it some interrupt has been occurred to that process, it will again go to the ready state. Or some additional, we can say, input output things it required. That process requires some input output operation. That process requires some another files to complete this execution. Then it will move from running state to the ready state, and that CPU is allocated to the another process. Okay, such a situation is called as context switching. Some suppose we are switching CPU from one process to another process. That is context switching. Okay, then suppose the process execution is completely complete, or we can say its execution is complete, so it will goes to the terminated state. So process can be terminated by two ways: by completing its execution, or system decide that the process will not go longer, or process will not complete anymore. So at that time process is terminated. Okay, and some waiting state is also there. Suppose process is running state, it requires something, it will goes to the running, it's waiting, then waiting complete, it will again go to the ready. Okay, ready again will go to the running. The cycle will completely we can say in a loop until the process is not terminated. Okay, fine. So these are the process states. So for every process they require a PCB. So what is PCB? So process control block. So what it is? So it's just a block, or it's, we can say, it's a file. So every process is create, the PCB is create. So every process information stored in that PCB. So what type of information stored in that PCB? So first is a process state. So process state means in the process executing in which state. As we have seen, the process is in new state, the process is in ready state, the process is in running state, or the process is terminated. So PCB first, we can say type or first things is that process step. Process number. So every process require a unique number that the system can identify it. So process number is there. Okay. Unique integer number is there, and that is allocated to that process. Another is program counter. As we seen that the program counter is always incremented by one. Suppose the program or the program is a set of instruction and the program is execution is process. So every instructions are there. Suppose the program completes one instruction, PC is incremented by one. PC in the sense program counter. Okay, so it is incremented by one. Suppose the program or the process complete 100 number of instruction, the PC value program counter value is 100. Okay, some registers are there, so which is helpful to that process for running, for storing information. Okay, so ARAG, PRAG. Okay, then memory limits are there, means the process are memory limits, means the process required how much memory, the process memory required by that process, or memory locations. Okay, list of open files. List of open files in that process required some additional files to complete the execution. So it supposed to open that file to complete its execution. That is list of files, list of open files for completing its execution. Okay, see that all the information about that process are in PCB. Okay, PCB program control process control. Okay, means all the information regarding that process which is in PCB. Okay, next, CPU switch from one process to another process. Just I have told you that context switching. Context switching in the sense the process switching the CPU or process print that from one CPU is print from one process to another process. So it requires to save all the information about that process in PCB. Okay, suppose the how many instructions have been completed. We have to update PC program counter. The program now the process in waiting state, so we will have to update the, not will have operating system have to update the process state. So all the information when context switching has been done now, means program process or CPU is switches from one process to another process, the PCB should be updated. Okay, see, P0 process is executing now and P0 is going to be switch. So whenever P0 is switch, we have to, operating system have to save its state to the PCB. Then P1 has to be in execution. Then reload the state from PCB1. PCB1 means suppose we can assume that P1 has a older process than P0. Then we will see that how much in PCB we will see PCB1 process 1 PCB. So we will see how much execution has been completed of process P1, and we will reload that PCB, and according to the PCB we will start its execution. Again, see, some execution has been happened and interrupt or system call is there. Then again we will reload the P0s there. Again we will reload PCB of 0 with process 0 PCB over there. And according to that PCB, we will continue its execution. Okay. So another concept of process is like a thread also. So what is thread? Thread is the same lightweight process, but every time we need to update PCB. So for PCB for process PCB is there, and for thread TCB is there. Thread control. What is thread? Thread is a lightweight process of the lightweight process, means uh, For executing process, operating system have to involve too many things. For executing thread is a very small work, we can say. It has come, complete its execution and go back to its back state. So no, nothing is too much involving in that. So thread is better than process. So that is the next part of our session. So we will see in the next session. Fine. Chalo. So we have completed today's session over here. So what we have learned? Process. Program, first of all. Program becomes process when it's in execution. Program states, which is very important. PCB, which is also very important. And context switching means process CPU switching from one process to another process. Okay. Chalo, fine. Chalo, take care.